Today we're going to go ahead and start into our next section, which is dividing fractions. Hope you guys remember last time we did multiplying fractions, we told you specifically to get ready for this. Ethan, no. You already jumped at once. Do not lean back in the chair, please. Okay, on dividing fractions, it's actually just as easy as multiplying. However, we've got one extra step. Guys, please quiet down. When we are dividing fractions, we're going to go ahead and use our two colors again today to help you visualize. Once we've done the models, you're not going to need the two colors anymore. The colors is just to help you see what's going on in these problems. So our first one, Mary Ann had 3/4 of a pan of brownies. If she wants to give each of her friends an 1/8 of a pan of brownies, how many teachers can Mary give brownies to? That's our question for the problem. So with these division problems, it's really helpful to think of these from a mathematical perspective and say, okay, here's all this information, but really, mathematically, what is it that I need to know from this problem? So if I look at this, what do I need to know? Kaden?
How many brownies should you give your team? How many teachers should you give brownies?
Okay, that's what the actual question is. But mathematically, what are you trying to do? I'll give you a hint. Am I looking at 3/4 of the 1/8 or 1/8 of the 3/4? Devin?
1/8 of the 3/4.
Okay, so what I really want to know is how many 1/8 are in 3/4. Does that make sense? That's really what our question is on this. Okay. So, I'm glad you did it, but let's look at it. We'll go do our model first to see it. So first we're going to go ahead and divide this into 4. And with our first color, we're going to color 3 of those 4. So divide it into 4s, and then color in 3 of the 4. Okay? Our second step is now to turn this brownie pan into 8s. So to make it into 8s, I've already got it in 4s. So I make it into 8s. And you do your second color. You're going to color the whole pan in so that we can figure out how many 8s there are in our 3/4. So we color in the entire thing. Now we're looking for how many of these 8s have 2 colors in them. So here's 1/8 that has 2, because I used blue and yellow, that made it green. Here's the second one, here's a third one, here's a 4th one, a 5th one, and a 6th one. So out of the entire pan, 3/4 of it, how many 8s did we end up with?
6.
Okay? Does everybody see that we have 6 of those 1/8 sections in this 3/4 of a pan of brownies? Make sense? Got it?
There's another and much easier way to do this.
How's this?
So what you do is you would put 3/4 divided by 1/8.
Oh, like this?
Yeah, and then you would switch the division sign to a multiplication sign.
Okay.
1/8 to 8, and then just multiply that, and then you get the answer.
Well, wait. If I switched that and I said 3/4, you said change it to multiplication?
Yeah.
Can I multiply it by just 8?
Or no, 8 over 1.
Well, you said 8. Is it 8 or 8 over 1?
8 over 1.
Oh, so it's just like this number flipped over.
Yeah. And then if you multiply them, you'll get the answer.
Then if I multiply, I get the answer? Let's see. 3 times 8 is
24.
24. 4 times 1 is
4.
4. 24 divided by 4 is?
6.
So mathematically, I can actually do what our model showed. Does that make sense?
That's just another way to do that, but my fifth grade teacher taught me.
Good. You sound like you had a pretty good sixth grade teacher as far as math goes anyway. So, what did we end up doing? Could I just divide that 3/4 into 1/8? Does that work mathematically? Can I divide by a fraction? I can't really, can I? Mathematically, that just doesn't function in my mind. But what I could do, and what Devin walked us through, so when dividing fractions, what we're going to do is multiply by the reciprocal. Does that word sound familiar?
Yeah.
You guys remember your pretest? There were 2 questions. It just said, what's the reciprocal of this number? How many do you think you got that one right? I don't think anybody did. Because none of you knew what reciprocal was, right? So, what is a reciprocal?
The second fraction.
Nope. A reciprocal is
The second.
the inverse of a number. Or to put it mathematically, flip it over. Okay? Now, another word that we use for this, I'm going to put this above this, is multiplicative inverse. And you'll hear those 2 used interchangeably. Multiplicative inverse and reciprocal are 2 mathematical words for the same thing. It's kind of like saying add or sum. Same deal, right? There's 2 different ways to say it mathematically. Same thing here. Multiplicative inverse and reciprocal. Both ways of saying the inverse of a number, or in other words, flip it over. So is everyone okay with our first example? Okay, so let's look at our next example. Now, Martha has 3 bags of chips. She's going to give each of her friends a third of a bag. How many friends can she invite over? So our mathematical question again. What is it we're really trying to do in this problem? What am I trying to find out, Devin?
You're trying to find out how many times 1/3 goes into 3.
Okay, so another way to say that is how many 1/3 are in 3? That's a 3. So how many thirds are in 3? This is what I actually normally like to start with when I'm doing division problems. Because a lot of times students have a really hard time conceptualizing. If I have 1 and I divide it into thirds, how do I end up with a bigger number than 1? Does that make sense? Doesn't, right? But if I actually look at it, it'll make sense. So if I take my 3 and I divide them into thirds, so we're going to divide these into thirds. Now, our 2 colors, we're actually not going to color over each other this time. We're just going to use our colors, and we're going to alternate the colors for each block. Okay? So I'm going to do my first block in one color, because that's 1/3, correct? Then I'll use my second color for the second block. And just keep going back and forth between your 2 colors. Then we'll be able to see how many thirds there actually are in our 3 holes. So there's my first hole is done. The second hole is done. That would be if the smartboard cooperated. And my third hole is now done. Or close. You guys need more time, or are you about done? More time? So once I've got them all colored, if I count, how many do I have? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many friends could she have over?
Um,
Well, she doesn't want any chips. She wants chips, she needs 8 friends, right? Okay? Now, mathematically, what did we just do? So let's go back to our first problem. But now I've got a whole number. So what do I need to do on whole numbers?
Just make a denominator of 4. I don't know how to say it.
Yeah, that's kind of what Jayla was saying. So I make a denominator of 1, turn it into a fraction, an improper fraction. Now we do as we did on our first one. We keep our first number like it is, 3 over 1. I'm going to change the division to multiplication, and I'm going to multiply by the inverse. So the inverse, or reciprocal of 1/3 is 3 over 1. So now I have 3 times 3, which is 9. 1 times 1, which is 1. 9 over 1 simplifies to 9. That's what our model showed us we should have gotten, correct? So even though when we think about it, 3 divided by 1/3, and I tell you 9, that doesn't seem to make any sense. But if you can actually see it and understand what we did, I took those 3 wholes, divided them into thirds, that now means I have 9 pieces. Make sense, everybody? Yes? Okay, now one thing we did here, when I had a whole number, what was the first thing I needed to do? Put a 1 under any whole numbers. This is like a dead spot right there. Put a 1 under any whole numbers. Then multiply by the reciprocal. But we have to turn any whole numbers into an improper fraction first. Once we've done that, then we can multiply by the inverse. Everybody good on this page? Okay, go ahead and turn the page. Page 2. Now, John Baker has 7.5 pounds of flour. If each batch of biscuits takes 1 1/2 pounds of flour, how many batches of biscuits can John make? So, again, let's start with our mathematical question. What is it that I'm really asking on this, Lydia? Good. Well said. So how many 1 1/2 are in 7 1/2? So, I think the number is going to be smaller than 1 1/2, bigger than 7 1/2, or somewhere in between.
Somewhere in between. Yeah, it should be somewhere in between.
Do you think my final answer is going to be less than 1 1/2, somewhere in between, or more than 7 1/2? Because so far we've ended up with bigger numbers, right? Right?
Oh, wait. No, it'll be...
Yeah, we did.
It'll be more than 7 1/2.
Look at our first one. We said 3/4 by 1/8. We ended up with a whole number of 6. Our second one, we said 3 divided by thirds, I ended up with 9. So now that I'm doing 7 1/2, how many 1 1/2 and 7 1/2? It can be less than 1 1/2, more than 7 1/2, or somewhere in between. Think it's going to be more? No, Sean? What do you think?
It's in the middle.
You think it's in the middle? Well, that's right. So the first thing we need to do is get our 7 1/2. So we're going to have to divide them all into halves. Because right now I've got 8 blocks here, right? But how many do I actually have for my problem? 7 1/2. So I'm not going to make you color all of them. Instead, we're just going to cross out this last one, because that one's not being used, right? Okay? So this now represents our 7 1/2. So instead what we're going to do is use our 2 colors. to figure out what the 1 1/2s look like. So what I want you to do on this one, for each 1 1/2, make it one of your 2 colors. So I'm going to do the first one, I'm going to do in green. So there's a whole 1, 2 halves. Then I'm going to do half of the next box, so there's 1 1/2. Does everybody agree with that? Anyone disagree? Okay, so there is 1 1/2. I'm going to switch colors. I'm going to use purple for my second. Now I'm going to do the other 1 1/2 in purple. So there's a half. There's another whole 1. And just go back and forth between your 2 colors until you've colored in all of the 1 1/2s that we have in 7 1/2. See how many we end up with. So how many did we end up with? 5. I've got 1, 2, 3, 4, 5. Oops. I'll change this. So once I divided that into the 7 1/2 into 1 1/2, I ended up with 5 of them. Does that make sense? Can you guys visualize why that is now?
Yeah.
Now, Isaiah? Okay, if I look, I got 1 set of 1 1/2 here, right? I've got a second one here, third, fourth, fifth. So I have 5 sets of 1 1/2 in my 7 1/2. Does that make more sense? Okay? Now, guys, the whole reason we're doing the models is because, quite frankly, dividing by fractions it really does not make a whole lot of sense. But when I actually look at it and see the model, I can now see, okay, yeah, that should be 5. So now all we need to do is figure out mathematically, how do I get from a sentence like this to equaling 5? Well, what did we do when we were multiplying fractions and we had mixed numbers? Yeah?
You can multiply the whole number by the denominator and then add the numerator.
Yeah, I slam dunk, right? Turn them into improper fractions. So we're going to slam dunk. We've got to do that to both of them, don't we? So 2 times 7 is 14, plus 1 is 15. Divided by 2 times 1 is 2, plus 1 is 3. Now, heads up, quiz time. This is the single biggest error students make, is on this problem right here. Because when you're doing mixed numbers, for some reason, you think you're already done, but we haven't multiplied by the inverse yet, have we? So realize this is only our first step. Our second step is now multiplying by the inverse. So now I have to change this. I make it 15 over 2. I keep the first number, change this to multiplication, and then I flip my second one over, 2 over 3. So now I do my reductions. I've got a 2 on top, 2 on bottom, 3 and 1. Those go away. 5 times 1 is 5. 1 times 1 is 1. Grand total of 5. So there's our mathematical representation of what our model showed us. Does the math now make sense to you? Anyone struggling on the math piece of it? Which part are you struggling on, Isaiah?
How did you get this one?
The 15 halves and 3 halves? Okay, remember, here I'm still dividing, right? So I have to change it to multiplication. So I keep my first number, 15 halves, change it to times, then I use the inverse, multiply by the inverse. Now I did reductions, I could have just done it. 15 times 2 is 30. 2 times 3 is 6. 30 divided by 6 is 5. I just did the reductions before I did the math. Okay? Which on the whole on the classwork today, you'll see the importance of reductions. So dividing with mixed numbers, what was the first thing we had to do? Slam dunk. Or make improper fractions. Once we had the improper fractions, then what did we need to do? Then we multiplied by the inverse, the reciprocal. Do not forget that second step, guys. It's really, really critical. This is literally the biggest error that students make in dividing fractions. Is on the mixed numbers, specifically multiplying by the inverse after you have turned them into improper fractions. Don't forget you have to do that second step. Okay, we're going to look at the following ones. And actually, I'm going to let you guys have about 2 minutes. Go ahead and solve these three. What you guys notice? Got it?
All of the answers are 1.
Ooh, did everybody get 1 for all your answers?
Yeah.
Then you didn't get 1 for all your answers. Let's check this real quick. That seems odd they'd all equal 1. Okay, so our first one. 4 times 5 is 20. 5 times 4 is 20. 20 over 20 is
1.
Okay, I guess you're right on the first one. Second one's definitely not 1 though, right?
Yes, it is. 7 times 1 is 7. 7 times 1 is 7. And
What do I have to do? Make it a proper fraction by, as Jayla would say, She does it with emotion, she just can't put the words to it. So, 7 times 1 is 7, 1 times 7 is, I guess it was 1, wasn't it? Huh. Okay, what about the last one? What's the first thing I gotta do?
Slam dunk.
Slam dunk, right? So slam dunk it. 3 times 2 is 6, plus 1 is 7, times 3 over 7. Wow, it really was 1. Well, do you notice anything about the two numbers? Is there a relationship between those numbers? What do I call 4/5 and 5/4?
The commutative property.
No.
Like 7.
7 over 1, 1 over 7. How are those related? 7 over 3, 3 over 7. How are those related? What do we call that? What's the math term we just gave you? Reciprocals. So what happens when I multiply reciprocals?
You always get 1.
Is that always going to happen?
Yes.
Does it matter if it's a fraction, a whole number, or a mixed number?
No.
No. Guys, technically that is the definition of a reciprocal. The definition of a reciprocal is the number you would multiply a number by to get an answer of 1. So what do you notice? A number multiplied by its reciprocal equals 1. And yes, that will always be the case. Again, that is technically the definition of a reciprocal. The number you multiply it by to get 1. Now mathematically, the easy way to do it is to say, flip the number. Okay? And this is why division works this way. Because really, division and multiplication are what you call what? Inverse operations. So if I do the inverse operation with its reciprocal, did I actually change anything? No, I didn't. Because a number times its reciprocal equals what? 1. So by multiplying by its reciprocal, I'm just doing the opposite operation really with the same number. Everybody tracking so far? Okay, let's do our last set together, and then we're going to let you guys get some extra practice. So, actually, before we do this one, I'm going to let you guys get some practice on it. When is lunch? Remember that all these are going to be the same, guys. Our whole idea is I need to get to 2 fractions then instead of dividing, I'm going to multiply by the inverse, okay? So, our first step when I've got mixed numbers, we have to send up. Okay? So we multiply then add. 3 times 3 is 9, plus 1 is 10. 5 times 2 is 10, plus 2 is 12. So right now we've just slam dunk. This is the one that I warned you guys is going to be the most commonly missed. Because you think, oh, I've already done something. Yeah, you have, but I still have not yet multiplied by the inverse. So Ms. McShann is not going to like this, but I'm going to teach you something that has always helped me in dividing. The very simple phrase. The first thing we're going to do is keep the first number like it is. So I'm going to rewrite the first number. Keep it. 10/3. And I'm going to change the sign from division to multiplication. And then finally I'm going to flip the last number. Instead of 12/5, it's going to be 5/12. KCF. It's kind of like my favorite chicken, just a little bit backwards.
Is that why Miss McShann is going to like you? Because you flipped KMS?
Because she prefers to think of it mathematically as multiplying by the inverse. But it actually, in order to actually do it, it helps to think, what's my steps? I keep my first number, I change and I flip. I multiply the first number by the inverse, okay? So, now that I'm here, I can start looking for reductions. So now it's a multiplication problem. Can I reduce when it's division? No, I cannot. Please don't reduce when it's division. Reduce once I have multiplication. So now I've got this, I can divide these both by 2, gives me a 5 and a 6. I can't do 2 tops, can't do 2 bottoms, I'm done. 5 times 5 gives me 25. 3 times 6 gives me 18. 18 goes into 25 once with 7 left over. 1 and 7/18. Pretty easy, right? A second one. Whole number. Yes, sir.
I got minus all that. So 7 plus 7, I got 14. 8
You didn't simplify. Yeah. Okay, we have a whole number. First step. Turn it into improper fraction. Now that I have 2 fractions, I keep the first number, 4/1, change the times, flip my second number, 8/3. Look for reductions. Again, that's where our 4 key numbers, 2, 3, 5, and 7 come in. I've got a 3 on the bottom, none of those ones on top work, so I can't do any reductions. So 4 times 8 is 32. 1 times 3 is 3. 3 goes into 32 10 times with 2 left over. Yes, sir.
If you flip the KCF around, then it's a KFC.
Yeah, kind of said that. But don't change those around or you get messed up. Our next one is just 2 fractions, so I can just go to keep, change, flip. I keep my first number, change the times, flip my second number, 9/4. So I've got a reduction on the 2's, gives me a 1 and a 2. I've got a reduction with the 3's, gives me a 1 and a 3. 3 times 1 is 3, 2 times 1 is 2. 2 goes into 3 once with 1 left over. Starting to see it?
Oh, I see.
Okay? So, to really see if you guys have it, turn the page. We're going to give you a whole page of nothing but big numbers. No, this is not the homework. No, these are all division sites. So I'm going to do the first one because I really want to reinforce the importance of reductions, guys. So watch what happens. All of these are just 2 fractions. So all of these, it's going to simply be keep, change, flip. Keep my first number. So I'm going to rewrite that as 7/14. Change my sign to times. with my second number. This time it comes over 18 over 7. Once I am in the multiplication, now I can reduce. So here I've got a 7 on top, 7 on bottom. Those I can both reduce by 7, gives me 1 and 1. I have a 14 and an 18. What can I reduce those by?
2.
2. That gives me a 7 here and a 9 here. 9 and 7. Can I do anything else with those? Go through your numbers. Can I divide them out by 2? Nope. 3, no. 5, no. 7, no. Say no 4 times, you're done simplifying. 1 times 9 is 9. 7 times 1 is 7. 7 goes into 9 once with 2 left over. Now, for those of you who do not like reductions, great news. You don't have to reduce. Okay? Instead, I can go and I can do 18 times 7. That gives me 56, 126. So I go 126, and then I've got 14 times 7. That's going to give me 28, 98. So I have 126 and 98. What can I divide both those by? Because we always still have to simplify, right? What can I divide 126 and 98 by? 2. Good. So I can divide those both by 2. That's going to give me 63 and 49. Okay. What can I reduce 63 and 49 by? No, 49 doesn't work for 3. Can I divide them both by 2? No, neither of them do. Can I divide them both by 3? No, I do the top and not the bottom. Can I divide them both by 5? By 7? Yeah, so I can divide it by 7. So that gives me 9 over 7. Oh, wow, look. What does 9 and 7 give me? 1 and 2, 7. So do I have to reduce? No. But now I've given you 1, 2, 3, 4 more chances to make a math error if you don't reduce. Because in any of those 4 steps, if you make an error, your whole answer is wrong. Was the reductions hard here? Seeing where the same numbers were on top and bottom? I don't think so. Especially if you focus in. For those of you that still don't have it, what are the 4 I focus on? 2, 3, 5, and 7. But it has to be 1 on top, 1 on bottom, and it cannot be until it's multiplication. You cannot reduce in a division problem. You can only reduce in multiplication. Everybody feel okay? Okay, let's go ahead and start working. You got about 6 minutes left until lunch. Yeah. Okay, looks like most of you actually did pretty well on this, so well done. My phone's still on, just making sure. Nope, you don't need a grading time. This is just practice, so. A really big key, make sure you're doing your keep, change, flip. So I keep the first number, change the times, flip my second number. The reductions are going to make this way easier for you. So I've got 3 and 9, I can divide both those by 3. I now have a 3 and a 12, I can divide by 3. 1 times 4 is 4, 7 times 1 is 7. Next one. Keep, change, flip. No reductions on this one, so now I just multiply. 5 times 2 is 10, 7 times 1 is 7. It's going to go 1 whole time with 3 left over. Our next one, keep, 4/18, change the times, flip, 4 over 1. Remember, I cannot do 2 reductions on top, guys. It always has to be 1 on top and 1 on bottom. So the only one I can really do is 2. Gives me a 2 here and a 9 here. 9's not going to go to a 4 or a 2. 4 times 2 gives me 8. 9 times 1 is 9. Keep, change, flip. Here we've got 4s I can take out. It gives me a 3 and a 4. Then I've got another 4. I can do 1 and 2. 1 times 1 is 1. 3 times 2 is 6. Next up, 1/2. 10 over 5. So that gives us 1 and 5. 1 and 1. All we got left is 1s. So there we just multiplied by its inverse, right? Next one, 8/20. flip 16 and 1, and divide those by 4, gives me a 5 and a 4. That's all I've got. 4 times 8 is 32, 5 times 1 is 5, so that's going to go 6 with 2 leftovers. Number 8, keep, change, flip. Well, here's one that makes reductions a lot easier. 7 and 14 gives us 1 and 2. 3 and 6 gives us 1 and 2. Meaning I just have 1 and 4. Then we've got number 9. Keep, change, flip. I've got a 3 I can take out. I've got a 2 I can take out. And I have another 2 I can take out. 5 times 1 is 5. 2 times 3 is 6. And then our last one. Keep, change, flip. I've got a 2 I can take out of those. That's it. 3 times 5 is 15. 8 times 1 is 8. Goes once with 7 left over. Make sense? I could. I'm actually pretty good with math. I am able to explain the homework.
Can you explain surprise?
You missed it, Miss Martinez. My only take on proper English. So if they want permission, they have to ask, may I?
Can you wait? You bring up proper English and then you put the period outside of parentheses. May I please get the answers for a while ago?
Okay. Okay, Mr. English major.
May I please get the answers?
Okay, on our homework. So this is very similar to what we've done before. The big question is, how's business? We have 4 different people that are responding. We have a tailor, garbage collector, an author, and a refrigerator salesman. So they're each telling us how their individual businesses are going. To find the answer, we go down here to the bottom. I will be honest, there may not be room here, especially if you write big. So use a piece of extra piece of paper. Just make sure you bring it so you show us your work. But I actually write fairly small, so it's not that hard. It's, again, just keep, 1/4, change the times, flip, 3/1. So 1 times 4 is 3, 4 times 1 is 4, my answer is 3/4. So anywhere in my puzzle that I see 3/4, I now put the letter P. So I can just go through, none in the first line, second line's got 1 here, 1 there, none on there, none on there. So there's only 2 P's in the entire problem. Make sense? You're just going to do that. No, not corny. Hilarious. Can't you read? It says 4 hilarious answers. Okay, they are good math jokes. So yes, you will find 4 answers. When you read them, it'll make sense based on who is saying them. But that's all I can give you on that. Okay? So honestly, this really shouldn't take you that long, guys, because all we're doing is dividing fractions. Keep, change, flip makes it very easy. Don't forget, when I have a whole number, what's the first thing I need to do, though?
Make a denominator of 1.
Make it a denominator of 1. We didn't throw any mixed numbers in there, so that should make it easy. Basically, you just got a few whole numbers. But don't get confused on whether the whole number comes on the first side or the back side.
Oh, you do have to simplify.
You do have to simplify, yes.
But don't make any mixed numbers.
And do make mixed numbers in your answers, but look for the improper fractions for the puzzle piece. But I do, in your answers, I do want to see that made back into mixed numbers. Any questions on the homework? Okay?